Good evening, meteorologist DT here with our winter preview update. This is the final report here, and I'll placing this on the website, the Facebook page, and on the YouTube channel for your consideration. So this is the forecast. Some of you may have already gone through this, but I'm going to go through it slide by slide in order to answer some questions and make some points here. So let's get started. The first thing I want to point out here is that sometimes, preconceived notions about what the winter is going to be like turned out to be wrong. Now, this is based upon the CPC forecast, but you could use this with other private forecasters, including my own. I've gotten many things wrong for the winter from time to time as well. But this is just one you can see. Now, this is based upon the mid-October forecast. So, if you take a look at the different information here, like for example, we'll start out, I guess, with 2013-14. You can see the warm temperatures were back in here, and they had normal for the east, and of course we had a very cold winter 13-14. 2012-13, they had a pretty warm winter, and that was okay. That was pretty close. 2011 and 12, they had the colds of the north, warm to the south, and it was warm everywhere. So that was a bust. This was a bust. 2010-11, well, they had the cold in the Pacific Northwest and warm over the southern states, and of course that was 2010-11 for the winter, so that was a bust. 2009, 2010, well, that was a big, huge bust. And then 2008 and 2009, you can see they had warm everybody, and of course we had the cold to the north, and then there was a nice area of near normal in between, and so that was a bust. And then finally, another one was the October forecast, 2014 for the winter of 2014-15. And this was another very cold winter, especially after December. December was warm, but January, February, March was quite cold. You can see there. And again, it did not work out at all. So, conventional wisdom, you got to be careful with it. It doesn't always work out well. All right, this here is an example of the winter forecast. Now, this is the actual data from the winter of 2017-18. The reason I'm pointing this out is because this was a moderate La Nina winter as well. And if you look at now, obviously we had this huge snow hole right here in DC, which frustrated a lot of people. But they had decent snow. The total was up to about 12 inches in central and southern Virginia, which isn't bad. And then in the Kentucky, then you had more, 2 feet snows in a lot of places in Pennsylvania, and really good snows in New England. So my point is that you can have a moderate La Nina without it being absolutely terrible winter. Now the snow hole in the northern Virginia, the D.C. area, that's hard to explain. That nothing to do with the climate process. That's just one of those things that happened. And you look at it more detail here. Again, 2017-18, you can see the snow hole right there in northern Virginia, D.C. And then, Richmond, Virginia had around there anywhere from 11 to 16 inches total. Lynchburg at 17 inches, wasn't bad. Pretty good winter for these areas, not terrible. Roanoke had, 25 to 30 inches there. But the northern Shenandoah Valley did not do well. Northern Virginia, relative to other places, did not do well at all. This is the winter of 2018-19. And again, you can see that this was a pretty good winter as well. Not bad for the Mid-Atlantic region, and pretty good snows much of the country east of the Rockies. Total snowfall for the season. And this was the winter of 18-19. Again, this is pretty close to the same map, but just a little more enlarged here. And you can see, again, if you look at this yellow stuff next to the blue, that's 12 to 24 inches total for the season. Which, if you look at it in detail, you can see we have 15, 16, 18 inches in central Virginia, 24 inches in Charlottesville total, up to 30 inches into close to D.C. So it was a pretty good winter. And then we had the winter of 2019-20. I should say 20 up there instead of 30. But you can see, again, this was not a good winter last year. You can notice also we had this big snow hole right here in central Virginia. They actually had more snow in North Carolina and southeast Virginia than did in western North Carolina, central Virginia, all the way up towards D.C. and Richmond and Baltimore. And so it was a pretty bad winter season last year as well. So just to give you an idea. So these are different examples of recent winters. Generally there are 3 types of winters in the eastern United States. There's a severe winter, which features, or a prolonged winter. Normal winter, climatological winter. And then a mild or rainy winter. So, you look at the winter season, December really into March is talking about 12 weeks here. I include March because, March is often, last 10 or 15 years, we've had a lot of snow and cold in March, and December is often more like a continuation of November. But if you include 12 weeks of when you could get snow and cold, December, January, February, March, Typical winter, you'll have 6 weeks of winter weather, and then you'll have, 4 or 5 weeks of fairly mild conditions. So a severe or prolonged winter, where it could start early, say mid-November or last into March, or it can go into, start in December, go into April. Okay, or you can be a winter where it starts in early mid-December and it goes balls to the wall crazy until the middle of March and then it breaks down. So you can have periods of near normal temperatures for most of the winter with a lot of moderate or significant snowstorms, or you can have intense periods of severe cold followed by mild temperatures. So examples of these types of winters would be, the 76, 77 winter, which I'm sure you know of, the severe winter of 77, 78, 95, 96 with the big East Coast snowstorms, 2002, 2003, another severe winter, the winter of 2009 and 10, and the severe winter of 2013, 14. Then there is the normal winter, where it's typically begins in mid-December, but it might hold off until Christmas. It will often feature, cycles where we have a week or two of 10 days of cold, then we're mild, and it's fairly quiet. Then it's cold again, back and forth. Usually it has a typical January thaw, the normal winter. And like I said, it can start in early or mid, even late December, and then you'll have like blasts of cold weather until March, and then it breaks down. Usually there's an interval where you have like 2, 3, or 4 weeks of really cold temperatures and a lot of snow chances. You can also have an area of the country where, like, New England's getting hit a lot. A couple winters ago, we had all that monster record snow, December, January in New England. Then a pattern shifted, and then they went out of their snow cycle. So, that's a typical winter. And examples of that again would be the winter of 2017-18, the winter of 2014-15, which had a mild December. Then we had very cold and stormy January, February, March of 2015. The winter of 2010-11 and 1986-87. So that's a pretty typical winter. And then the mild winter, which of course some people like, some people don't. It's mild most of the time. So the whole winter is, persistently mild. The winter gets to a very late start. Sometimes you don't have any big cold air outbreaks until until last week of December, or maybe even the first week of January. Usually you'll have below normal snowfall, sometimes much below normal snowfall for most of the eastern half of the country. And you'll have a lot of days where temperatures are above or much above normal. Even a week or two of really above normal. And then often a mild winter, by definition, often features no widespread Arctic outbreaks. And examples of this: winters of 72, 73, 73, 74, 2001, 2002, 2015, 16, the La Nina winter. Now, we did have a big snowstorm there in January 2016, but the winter was quite mild. And of course, the record warm and dry and snowless winter of 2011 and 12. So, all seasonal forecasting, is 1/3 science, 1/3 art or intuition, and then 1/3 guessing. And the way it works with me is first you have your pattern drivers, which sets up the whole winter. Then that affects your teleconnection. That affects your daily weather. So that's the type of how I look at things here. All seasonal forecasts, like I said, is based upon a key set of assumptions about the atmosphere. Large-scale hemispheric forces known as your pattern drivers. These would be your El Nino or La Nina, or even neutral conditions, which would be La Nada. You could have your PDO, your QBOs, and your sea surface temperatures, the soil moisture, the snow cover in Siberia, if that's significantly different from the normal. These are all different things which are pattern drivers which affect the teleconnections and how they're going to shape up. And then you have your teleconnections, which would be, the Arctic oscillation, the EPO, the NAO, the TNH pattern, and the PNA. So these are all different teleconnections. We'll go into them in a little bit. And then these teleconnections set up the low pressure and your high pressure, your troughs in the jet stream, your cold fronts, your warm fronts, your prolonged warm spells, and your cold spells. So pattern drivers, teleconnections, daily weather. Just, keep this in mind, and you'll understand weather a lot better. All right. Key assumptions also have risks. They really do, folks. Consensus forecast, for example, the summer of 2017 called for moderate El Nino. And if you go back and take a look if you just Google hurricane seasonal forecast 2017, you'll see below and much below normal forecasts in April and May from everybody. And of course, we had a very active hurricane season. And so a classic example of groupthink. So that's just to keep that in mind. Consensus carries weight in science but it doesn't always work out. You have to allow for things to go wrong sometimes, and for other parameters which you are overlooking to take to become a dominant feature. So consensus matters up to a point. Like key assumptions about our winter. This is my view. Some people may be different, but this is my view about the 2021, the pattern drivers. Moderate La Nina into early January 2021. Okay, then it's going to steady weaken, maybe rapidly weaken in February, March, and April. So the key issue is how fast does the moderate La Nina weaken? Now, a lot of people have the moderate La Nina staying through the winter. As you'll see in the data does not show that. That's a mistake if you're thinking that, in my opinion. The autumn, right now, there's no autumn trends discernible at all. I'm sorry about the typo there. With regard to the teleconnections, none. Arctic Oscillation, the NAO, the Eastern Pacific Oscillation, the PNA, nothing. I can't see any trend one way or the other. Current, long-term soil moisture trends seem to favor a trough being in the eastern United States, which would make this different from the typical La Nina. And of course, we are expecting a positive QBO to last throughout the winter at values that are around plus 10. So that's a factor to take into consideration. So this here is our ENSO map, which we've seen, I'm sure you've seen before. These are different regions. There's a lot of these different maps here on the internet you can look at, but this is the regions here. So again, region 1.2, that's off the coast of Peru. This is the key one, 3, 4. This is what we look at to determine whether something is El Nino or La Nina or neutral. And then there's region 4 out here by the Solomon Islands headed towards, New Guinea. So those are the different regions to keep in mind here. So let's talk about the La Nina. And this is a sea surface. This is a map from mid-November, November 15th, and you can see what where the cold water was. It's a really great map from the Climate and Analyzer website. And you can see the sea surface temperatures. I've highlighted La Nina. And then we have this huge blob of really warm water in the Northeast Pacific. And we'll talk about that as well, because that's going to be a big player. So this is just a chart here of the different types of El Ninos and La Ninas. Weak, moderate, very strong, strong and very strong. And so this is the one we had last year. We had a weak one, 1920 last year, going into the spring. And then La Nina over here you can see. And then this is the one 2017-18. Remember I talked about that. That was a recent one. We had the moderate La Nina, 95, 96, when you had the big snowstorms on the East Coast. So that was kind of impressive. So, there are winters out there, which even with La Ninas aren't always bad winters, and that's an important point to consideration. Now, the very strong winters for El Nino, this was a mild winter, this was a mild winter, this was a super mild winter. Strong ones, this was a great winter, 95, 90, 57, 58, 65, 66 was pretty good. So, and then other winters down here, this one here sucked. So, it's hit or miss, but so it could be a mistake to make a categorical assumptions that all El Ninos mean this, all El Ninos mean that, and I think you see a lot of that in these forecasts. This is another way of looking at the same chart, but here it's on a graph. And this is the ONI, Oceanic El Nino Index, and this goes back to, I guess, 1990. This isn't the early, but you can see the different peaks here, 91, 94. So these above this line here, this is the upper part of the graph. This here is 0. So this is all your El Nino in here, and these are all the La Ninas down there. So, this is a nice way of looking at things. It gives you an idea of how you chart these things. And you can see that 2015-16 was very strong. 97-98 was strong. This was the great winter, 95-96. This was 2009 and 2010 was the weak one there. So, it's a nice graph. I think it's really useful. One thing I want to point out here, there is a myth that La Ninas strongly correlate to mild eastern winters. I just think that's a myth. And a cold and snowy Midwest. There are big differences between weak La Ninas and moderate and strong La Ninas. So now if you look at all La Ninas together, and this is what a lot of people do, I've seen this private forecasts, I've seen this on TV, they look at all La Ninas and they come up with this map. And if you look at all La Ninas, together, this is especially for moderate and strong La Ninas, you'll see you get this sort of bias for temperatures. Pretty warm in the southeastern states, really cold up in the north, Minnesota, Dakotas, into the upper plains, and then, near normal in New England and the Great Lakes, and then fairly mild, the Ohio Valley, Mid-Atlantic, and really warm in the southeastern states. But again, I think this is a mistake, especially for location and intensity. Here's another different way of looking at La Ninas. If you have a La Nina which is west based, that is to say out here in ENSO 4, the coldest water would be here, then you get this sort of pattern where it's much warmer. But when you have a east-based La Nina, which is when the coldest water is here, these are much less warm temperatures, and the cold is a lot stronger and more widespread and further to the east. So it does make a difference where the La Nina is going. So again, simply just saying, well, La Nina means this is a mistake. And if we look at the actual data, now these plots show that this particular La Nina is east-based. So let's look at the data. We'll see it very clearly. This is region, now this is as of November 21, so this is region 1.2. It's been the coldest, and you can see it's around minus 1.26, and that's dropping again a little bit. This is region 3, which has consistently been around minus 1.2, minus 1.4 all the way through. You can see that. There it is, the latest reading, 1.22 negative. This is region 3-4. 1.26. It reached a peak low point here, and then it rose again. Now it's dropping off a little bit again. So the region 3-4 is going back and forth with a narrow range, and then region 4, which is, as you can see, the warmest of the values, at negative 0.73. So clearly this is an east-based La Nina from what I can see. Now maybe that'll change, but that's what it looks like to me right now. So our uncertainty here is La Nina. What does it mean? From the winter. Is it going to be weak? Is it going to be moderate? Is it going to be strong? These are the subsurface values here from the TAO buoys, and you can see as of late October, we had a pool of minus 5 degrees centigrade in the upper left here. See that? Right here. And then, of course, by November 11th, that had weakened, disappeared again, and now it's come back. The new data as of a couple of days ago was like minus 4 centigrade again. So it's going back and forth, which tells me that the thing is probably peaked. It's probably not going to get any stronger. And indeed, that's kind of what the data is showing. Now, this is the IRI climate models from October. And you can see, let me point out something here. You see the blue line? Okay, this is the CPC forecast. You can see that right there. Okay, and you can see how much colder it is than everybody else. It reaches a peak here in December, January at around minus 1.5. But the other red line and the green line, the mean of the dynamic models and the statistical models, these are the statistical models, these are the dynamic models, are much further to the north, around minus 1. You see that for the mean. So the operational, the CFS, the CPC models are much colder than anything else. And I think that's a mistake. But indeed, if you look at the November model, look at what happened. The blue line has moved dramatically further to the north. It's warmed significantly. So now the red and the green line come down a little bit below minus 1, but they're no longer at minus 1.5. And the other point here is that this is January, and you can see that at this point here, January, that this is now going up. And then clearly in February and March is warming at a pretty steady pace. So this is telling me that the second half of the winter, maybe by mid-January, this thing is going to start breaking down. And that puts us into a weak La Nina, which is significantly different type of winter weather for the second half of the winter. That's what this is indicating to me. Okay, let me clear this out. Here we go. And then now this here is the this is the CFS forecast, and this is from November. And you can see it reaches the ensemble. The dash black line is around minus 1.8 here in January, and then look how fast it warms by February, March, and into April. I mean, this thing climbs like a rocket. So there is that. And then if you look at the other models here from the NME model website, you can see again that the CFS, which is the orange line, see this right here? Look how much colder it is than anything else. Okay, the NASA model, really cold. The other models are way up here. They had this thing, look what they had this thing down here. Ridiculous. Way overdone. It's just, it's just ridiculous. It's just, anyway. So, if you want to forecast that, you can. I'm not going that way at all. This is the Australians, and you can see it is leveled off. The Australians are very good with ENSO events. They're probably the best in the world, and they have this thing staying steady till January, and then it climbs. So that matches the other data as well. And then also, in case you missed it, this here is the European model in the upper left, and then we have the Japanese model. And again, if you look at the red line spaghetti, you can clearly see it reaches a peak in January, right here, January, and then it climbs. Same thing with the Japanese model. A peak here, and then it climbs. And somewhere between -1 to -1.5, -1.6 on both of these models, about the same thing, and then it climbs pretty rapidly. So, that's what I think is going to happen. I think that's very reasonable. I don't see any reason to go against that. Another point here is La Ninas. If you look at the precipitation patterns for December, January, February, strong, moderate, and weak. So the top images here are the strong ones, right through here. This is strong, okay, and then this is a moderate one, and then these are all moderate here, and then these are all weak down in here. All right, if you look at these, you have 21 cases. So, for example, in the deep south, 11 of the 21 cases had below normal precipitation, 5 had near normal, 5 above normal. In the northeast, from Virginia to Maine, you had 5 cases above normal precipitation, 13 near normal, and 3 below normal. And then for the Midwest, you had 9 cases of the 21 where you had above normal precipitation, 11 near normal, and 1 below normal. So clearly there's a bias for the Midwest for seeing good precipitation during the winter, pretty decent in the Northeast, and then below normal in the deep South as a general rule. With respect to temperatures, let me call up this one. There you go. Why isn't this showing up? Oh, I see. There you go. And then you go, this is temperature, same sort of thing. Out of the 21 cases here, you can clearly see, let me pull this up a little bit. You can again, same sort of thing. The deep south had 3 winters with below normal temperatures of the 21 La Nina cases. 9 near normal and 9 above normal. The northeast, from Virginia to Maine, had 6 examples which saw below normal temperatures for the winter, 11 near normal, 4 above normal. So that's 17 out of 21 with normal or below normal temperatures. That's pretty good for the Northeast. And the Midwest, we had 10 cases of below normal, 7 near normal, and 4 above normal. Also, that's so pretty good. So again, I think it's a mistake simply to say all La Ninas mean this, all La Ninas mean that. In addition, take a look at La Ninas here when you have a positive NAO. When the Greenland block is not there, when you have a large upper low over Greenland, the vortex, some may be located there sometimes, a positive NAO here. In those 3 months, you get a blowtorch the whole December, January, February, if that happens. If you have neutral La Nina, then December's kind of cold. January and February fairly mild, those southern states, as you can see, into the mid-Atlantic. But if you have a La Nina with a negative NAO, that is to say the Greenland block is in place, then you have a much colder winter everywhere, especially the eastern United States. So I think that's significant. Here we can take a look at Albany and Boston for different types of La Ninas with snowfall. And we will notice here, let me call up my mark, and I'm going to change the color so you can see it a little bit. This is a weak La Nina here. So there's the mean of all the snowstorms with weak La Nina, and it's right on the normal mean in Albany. If we go into weak La Nina in the second half of the winter. This is a moderate here, not, it's a small sample set, but it's a little above normal. This is Boston, moderate La Nina, a little below normal, but weak La Nina is, again, almost right at normal. So that's for those 2 areas, and we can go to the next one. Oops, I'm going to call it out here again. And there we go. This is Indy, and you can see Indianapolis and Richmond. And same sort of general thing here. Moderate in Richmond is very close to the mean. La Nina weak is a little above it. And in Indianapolis, same sort of thing. Very close to the mean for weak and a little below the mean for moderate in Indianapolis. Let's see here. That was Albany. We did the first one was, yeah. And then this one here is Indianapolis. And then this is in Pittsburgh, I'm sorry. Pittsburgh, you can see moderate La Nina as well for winters with below normal. Again, for moderate, it's in Pittsburgh. That shows a strong below normal there. But weak La Nina in Pittsburgh, if it goes weak in the second half, is above normal. So that's a good sign there for western Pennsylvania and the Ohio Valley. All right. So now we know about what La Nina's mean and what is it for about this upcoming winter. So it's pointless to claim that La Nina means XYZ for the winter for this area. The data clearly shows there's way too much variability to support such a claim. Moderate La Nina is here. We know that for a fact. It will stay moderate through most of December into early January. All the model data that I showed you, that I've seen, shows La Nina will weaken at a steady pace. About 65 to 70% of the model data shows rapid weakening in February and March. Weak La Nina winters are very different from moderate to strong ones. And the implication here is clear. The second half of the winter is going to be very different from the first half of the winter. So, are there any analogs to this current La Nina which might give us a clue? Well, we can look at the data. These are the data tables here from CPC going back to 1950. Now, Eric Weber over at Weber Weather, you can go there. He has the data going back to 1900. So even more data. But you can look at these different years and you can find analogs. You go through these data tables. This is what meteorologists do. And you come up with some analogs. So what we're looking for is a El Nino event which began, a neutral in the summer. Okay, as you can see here in the green box in May and June and July, and then developed moderate La Nina in the autumn into the winter, and then weakened late January, February, March of the next year. So those analogs would be 1964-65, 1995-96, which was a good winter. So was 64-65, 2005-2006, 2008-2009, which wasn't bad, and 2017-2018. So all of four of these five were pretty decent winters. And if we look at the temperature anomalies, what does it mean? Well, there you go. If we look at these El Nino, these ENSO winters, these La Nina winters for December, January, February, in the upper left we have our precipitation anomalies. And it was a little on the dry side in southeast Virginia down to the east coast, not too bad. Every place else was pretty close to normal. And the temperatures, they were fairly cold in the northeast and the interior, near normal in Virginia, Maryland, North Carolina, and then pretty close to normal in the Midwest, below normal Illinois, Indiana, Michigan, Missouri, and even the deep South was not particularly warm. So these are pretty good years in terms of that. Now, with regard to precipitation, that was precipitation. With regards to temperatures, look at that. That's a fairly cold. That's not warm at all, and it's not severely cold, but yeah, it's not bad. And then you can see here that and these maps here. Now, this is December through February, and then this is January to March. This is the second half of the winter. You can see it's a little warmer here in the second half of the winter. So this one here, December to February, these are precipitation anomalies, and then the second half of the winter, it's much wetter, as you can see here. So that's really what we're looking at. So these are decent analogs for La Nina winters. They're not great, but they're not bad. So key assumptions about our winter 2019 and pattern drivers. Another one is the soil moisture. We talked about that. The soil moisture, just like when you have Atlantic or Pacific Oceans, where you have large, long-lasting pools of warm water and cold water that can affect the climate patterns. Sustained areas of saturated grounds or droughts can also affect weather patterns. This is an example. This is the rainfall pattern since July, and notice how dry it has been in the plains and the Midwest and New England to some degree, but how wet it has been over the southern states, from Virginia down to Louisiana, Arkansas. And that's because of the 13 named tropical storms and hurricanes which hit the Gulf of Mexico and moved into the southern states. We can see this here. This is the soil moisture anomaly as of late October. You can see how wet it has been. And this is where it was in July. So it has really turned wetter here. Again, that's because of the 13 named tropical systems. So all things being equal, large areas of expansive drought in the western CONUS and saturated grounds over the deep south implies two things. First, it implies that the classic La Nina pattern, which has a ridge in the jet stream over the southeastern states, may be weaker than normal. And that implies a colder pattern for the eastern U.S. And then once La Nina weakens, the overall jet stream pattern may favor more ridging on the west coast and more troughing over the eastern United States, which would be a P&A pattern, a positive P&A pattern. So key assumptions about the pattern driver. Let's look at the sea surface temperatures in the northern Pacific. So do you recall the severe winters of 2013-14 and 14-15? Remember how cold it was in those winters here? They were very impressive winters, especially the second January, February, and March of 2015, very cold. One of the reasons why they were cold was because of the blob. The blob refers to a huge pool of super warm sea surface temperatures in the northeast Pacific, south of Alaska, off the west coast of Canada, that formed in November of 2013 and caused an uncommon upper air pattern known as a positive TNH pattern, TNH tropical northern hemisphere, which was the driving mechanism for both of those winters. And that's why they were severely cold. Now, this was the classic January TNH pattern here. And this is where you can see what happened here. This enormous area of red here, this matched the blob exactly. So this blob was feeding this huge ridge, which expanded up into Alaska and the North Pole, and that created a trough, a massive trough over the central and eastern United States, which send the pattern, plunging southward with cold air. And it was a very impressive, severely cold winter because of that. And that stayed around for a long period of time. Now, if we look at the current sea surface temperature map, this was as of mid-October, early October, and we can see the warm water is located right along the west coast of North America. Now, this looks like a positive PDO, Pacific Decade Oscillation, and then a positive PNA if this were to hold into the winter months. But what's happened is, as you can see here, that has moved away. The blob has moved from being along the west coast of North America into the northeastern Pacific south of the Gulf of Alaska. Now, this looks very much like what we saw in 2013, 2014, and again 2014 and 15. So I am concerned that if this blob does not fade, we could end up with some intervals of really severe cold. That's a possibility here. I'm not forecasting it, but that's, if I had to think outside of the box here, that's what I would be thinking. If I had to think outside of the box, that's my concern here. I'll show you with the TNH pattern what it looks like. Now, this is the jet stream map showing you the PNA pattern, which is, a lot of us are familiar with this. This here is there's your ridge on the west coast. Oops, I'm calling a marker again. There's your ridge on the west coast. There's your trough on the east coast. Well, the TNH pattern is different because what's happened is that this warm area in the ridge over the west coast of North America is now here, and you have a much broader gargantuan trough here. So what happens is that the ridge expands up into Alaska. You see what it does here? And that's exactly what happened back in 2000. You can see it happening here. There you go. You can see it happening in 2015. Notice how the ridge off the coast, the west coast of North America, expanded up into Alaska and the Arctic region. So that's what it does typically there. So I'm concerned about that. With this new super pool of really warm sea surface temperatures hold into the winter, or will it dissipate? I don't know. If it holds into the winter, it's going to be a problem. And then finally, here's the QBO, the quasi-biennial oscillation. That's the wind at the top of the jet stream, which way above the top. It's hard to describe it to people. Sorry, from the beginning. The QBO is a high-level wind. It was discovered actually back in World War II when they were bombing Japan, and this very strong level ribbon of wind at the top of the atmosphere along the equator. That's where it really is. And it goes from cycles where it goes from neutral, where the winds are very relaxed, to strongly positive, where they're blowing from west to east, to strongly negative, where it goes from east to west, then back to neutral. It goes through these cycles up and down, back and forth, strongly positive, neutral, strongly negative, so on and so forth. And the cycles never repeat. They can even go back and forth. I mean, sometimes you'll have a QBO cycle where it'll be blowing strongly out the positive, then go back to neutral, and then go back to positive again. It never goes to negative. So it's a very interesting phenomena, and it's a useful forecast tool, but it's not really well understood. So why is this QBO thing important? Well, strongly positive QBO values correlate to non-blocking patterns in the jet stream, especially when they're higher than plus 12. Strongly negative QBO patterns, the really strong, can also lead to positive Arctic oscillation NAO patterns. So the AO stays positive, the NAO stays positive, and you have a shitty winter, or a mild winter, depending on your point of view. Well, the QBO values, which are neutral to moderately negative, let's say from +5 to -15, seem to favor blocking patterns in the northern hemisphere more. If we look at the current data, this is the data, again, goes back to 1950. We can see all this information, and you can look at the data at some point. The negative numbers are when the QBO is blowing all on the equator, the top of the equator, at 30 millibars from east to west, and the positive values are going from west to east. So you can see that data here. And if you look at it in more detail, this is what's really interesting. So this is the bottom number line here where it says 2020. So look what's going on here. Let me change my marker color here so you can see it a little more detail. So in January we were minus 2.5. See that we're weekly negative. See this right in here, all weekly negative right here. Okay, and then we went to neutral right in here, and then we started going positive again, and now we're at plus 10.8. See that? That was the value here in October, and the new value is around plus 12 right now. In mid-November, plus 12. So that's where we are right now. It's going positive. So what we're looking for is a pattern where it started negative, went to neutral, and then went positive. And there's not a lot of years that match that, but one of them, but there are some. And if we look at that, we can see let me pause so you can see a little more clearly here. The years are 1961, 62, 69, 70, 80, 81, 85, 86, 2008, 2009, 2013, 14. Some of those were pretty good winters. And in particular, 2013, 14, which was a severely cold winter because of that positive TNA pattern, which I talked about. Take a look at what the QBO did in 13, 14. Negative, see that? Negative here, and then neutral, and then positive. Very similar to what we're seeing right now. So that has me worried a little bit as well as 13, 14 is being a viable possibility. Maybe I'm wrong about that. Anyway, if you look at these particular analogs, you get this kind of pattern. That's a T&H pattern almost. That's a pretty deep trough, and that's a lot of blocking here. That's a pretty active winter if that's correct. That's just, of course, these are just analogs. We don't know if it's going to be correct, but you can see a lot of ridges, a lot of deep troughs over the, and that trough is fairly far to the south. So we'll see if that happens. It's speculation at this point, but we'll see. And if you look at our anomalies here, again, we'll start out here on the upper left. This is December to February. This is precipitation anomalies, and the bottom right are temperature anomalies. The precip is near normal, and the temperatures are pretty cold in those analogs. So in summary, all right, finally here, what we're looking at here is an east-based La Nina, which features a weak ridge in the jet stream in the southeastern United States. This means not as mild and more variable storm track. Still, there is a bias for better storms in the Midwest and the Ohio Valley, but the storm track will not be as dominant as with a typical La Nina, more variability. The saturated deep south also means less of a ridge in the jet stream in the southeastern states. If there was not a moderate La Nina to begin this winter, the saturated grounds in the deep south would be a signal for an active East Coast winter. The vast majority of ENSO models are showing La Nina weakening in the second half, possibly as early as mid-January, clearly in February, March. The implication is that the second half of the winter is going to be pretty darn active and cold. We'll see, but that's what it tells me. There is a risk of a 2013-14 or 2014-15 winter for the central and eastern U.S. I'm not forecasting it because you don't forecast extremes in seasonal forecasts, but it would not surprise me. This could be the black swan event if people are overlooking it. So I'm just, keeping that in mind. And then now in that regard, the risk for big East Coast snowstorms or nor'easters, the really big ones, is a little below normal until the La Nina breaks down. Now, after the La Nina breaks down, late January, February, March, it'll go back up and maybe even be above normal. But right now, it's below normal for the first half of the winter. And then finally here, that's the end of the forecast. Anyway, hopefully this has been useful and you enjoyed it. I said I would do a video explaining it, and I did it. It took a long time to do it. Anyway, this is Meteorologist DT. I'll see you on the Facebook page and on the Twitter page.